Welcome to Meaningful Magical Math. Today I want to use an area model to show you how to work a division problem. But before doing that, I want to review multiplication area models, since division and multiplication are inverse operations. Division is just backwards multiplication, and multiplication is backwards division. So let's start with 138 times 7 and make an area model to show that. Remember, an area model is a rectangle, a smaller model of a larger rectangular array on grid paper or graph paper, and let's break apart our 138 into 100, 30, and 8. This is the expanded form of 138. And let's multiply 138 by 7. So we'll have 7 rows of 138 columns. So this middle here, this inside, will be my area of 138 times 7. So let's do 100 times 7. We know that to be 700. Let's do 30 times 7 in this area. 3 times 7 is 21. We're multiplying by a product of 10, so 210. And let's do 8 times 7. We know that's 56. And we also know that in order to find our answer, we need to add 700 plus 210 plus 56 to equal 966. So my product is 966. Now let's find the same answers using a division area model. Let's start with 966 and let's divide it by 7, and we should come up with 138 because we know multiplication and division are related. So let's go ahead and draw an area model. And we know we're going to divide this area model into rows of 7. And we know inside here, this has to equal 966. But let's imagine we don't know it's 138 yet. So let's go ahead and start thinking of how many 7s are there in 966. Well, I don't really know off the top of my head, but I do know that I can use the hundreds place to think of how many 7s can go into 966. And I think I'll use 7 times 100 because that's 700, and that's pretty close. So let's go ahead and write our factor of 100 here in our area model. And remember, an area model is length times width, so 7 times 100 is 700. And over here, let's see how close I came and how much is left. So let's subtract. 6 minus 0 is 6, 6 minus 0 is 6, and 9 minus 7 is 2. So now I have 266 left here in this area. So how many 7s? How many 7s are there in 266? Well, I don't know for sure, but I do know that 7 times 3 is 221, and that's pretty close. So if I do 7 times 30, that's 210. I'm very close to 266. So let's write our factor of 30 in our area model. And remember, 30 times 7 is 210. And how close did I come? Let's subtract. 6 minus 0 is 6. 6 minus 1 is 5. And now I have 56 right here. So let's go ahead and think how many 7s are there in 56. Oh, I know that exactly. There are 8 7s in 56. 8 times 7 is 56. So let's put 8, our factor, up here in our area model. 7 times 8 we said is 56. And what's left over? Nothing. So now we have just divided 966. 700 plus 210 plus 56 is 966, remember? So we've just divided 966 by 7, and we found that it equals 100 plus 30 plus 8, which I can do the mental math and know that that's 138. Mathematicians call that our quotient, the answer to a division problem. And let's see how this is related. We see 966 here and 966 here. It's pretty sloppy. And we see 100 plus 30 plus 8 is our quotient, and 100 plus 30 plus 8 is what we multiplied our 7 by in our area model multiplication problem. And we see 138 is what we multiplied by 7 to equal 966. Now let's try another example. And let's not begin with the multiplication problem. Let's just go ahead and try to use, but we're not going to use that pen. Let's try to use 6,592 divided by 4. And we don't know this answer yet, so we're going to go ahead and begin with an area model to determine how many 4s, how many rows of 4 are in 6,592. So 4 times what is 6,592? I have no idea, but I do know that I can use my thousands place to help me get a good guess, at least get close. I know that 4 times 1,000 is 4,000, and that's pretty close. So let's use our factor of 1,000. Write this in our area model. 4 times 1,000 is 4,000. And let's do the subtraction. 2 minus 0, 9 minus 0, 5 minus 0, and 6 minus 4. I am 2,592 away. That means there's 2,592 boxes still left, or area still left in my area model. So let's go ahead and think how many 4s are there in 2,592. I have no idea, but I do know that 4 times 6 is 24, and that's pretty close. Oops. So let's go ahead and multiply that times the product of 600, and I'll have 2,400. And let's put our factor of 600 here. And we know that 600 times 4, we said, is 2,400. And let's subtract to see how close we are. 2 minus 0 is 2. 9 minus 0 is 9. 5 minus 4 is 1. And 2 minus 2 is nothing. So what's left over is 192. So how many 4s are there in 192? I have no idea. But I do know that 4 times 4 is 16, and that's pretty close. 4 times 4, 16, and if I multiply my 4 times 10, I'll have 40, and I'll have 40, and then if I multiply 4 times 40, I'll have 160, so that's pretty close. So let's take our factor of 40, and let's put it here. 40 times 4, we said, is 160. And what's left over? 2 minus 0 is 2, 9 minus 6 is 3, 1 minus 1 is nothing. So there's 32 left over that I'm still dividing. I'm still trying to determine how many 4s are in this number. So 4 times what is 32? Oh, I know that exactly. It's 4 times 8. 4 times 8 is 32. So let's put our factor of 8 here. In our area model, 8 times 4 is 32. And how close did I come? Nothing left over. So now, what is my quotient? What is my answer to my division problem? Well, it's here. 1,000 plus 600 plus 4 plus 40, plus 8 And I can do that mentally. That's 1,648. Now you may be saying, I don't see where 6,592 is. Well, 4,000 plus 2,400 plus 160 plus 32 altogether equals 6,592. And let's see how multiplication and division are related here. We see 4 times 1,000. Here, 4,000. We see 4 times 600, 2,400. We see 4 times 40, 160. And we see 4 times 8, 32. And when we add these together, we have our quotient, 1,648. Remember, a quotient is the answer to a division problem. We see our quotient here, and we see it here. I hope this has helped you understand how to use an area model to divide. Until next time, bye-bye.